Welcome to class. In this video, we're going to continue our review of power series because manipulating power series and re-indexing them is going to be a skill really important for differential equations. So let's talk about a few different strategies that I can play around with the indices on power series. One way that I can do that pretty easily is by just stripping out some terms. Let's say I wanted to strip out the first two terms of this power series here. Well, what I mean by that is explicitly write out the first two terms and then leave the series alone from there. So when I plug in 0, I just get C0. When I plug in 1, I get C1 times x minus x0. And now I'm left with the rest of the series. But now do you notice I've actually changed the starting point, in a sense, on my series. So this is a way that I can shift my starting point of my power series up, is just by stripping out however many terms I need to land where I want. Let's go to the next one. Alternatively, I could just artificially change my indices, and I could shift them around by a number. Let's say A. So let's suppose we were in some scenario where it would be convenient for us to not have k as my index, but maybe k plus a number. We'll say A. Maybe I want a k plus a up there. Well, what does that change? Really, I just need to shift my starting point in the opposite direction. So here I would subtract a from my starting point. Let's think about a particular example. If a were 1, and I wanted to change this index to be k plus 1, well, the first term in my series has a power of 5. If I'm expressing that power as something plus 1, well, what plus 1 is 5? 4 is. So to add 1 to my index, I compensate by subtracting 1 from my starting point. That way I'm representing the same sum of numbers, just in a different way. Arguably, the ultimate strategy is to just fully re-index your power series when you need to, even though it takes a little more effort. Let's look at this example. I think seeing an example alongside the strategy will help it click a little better. Suppose I was in a context working with this power series where algebraically it would be a lot easier if I just had the power k instead of k plus 2. So I want to write this to the power k. But do you notice I have all sorts of different stuff for k's floating around? I've got a regular k here and here. I've got a k minus 1 here, a k plus 2 here. But the power on my power series is the thing I want to be simple. So we usually come up with a new name to help us avoid getting confused. Let's just say n. That's another good counting number. So let's let n be the power, k plus 2. Using this little algebraic equation, I can figure out a formula in n for all of my other indices. Right? This tells me, for example, that k is n minus 2. If I subtract 1 from both sides of that equation, it tells me that k minus 1 is n minus 3. And do you notice when k is equal to 3, that tells me that n is equal to 5. And so I can replace each individual index with these guys. Right? So I'm going to swap k equals 3 for here. I'm going to swap the k here. Oh, we're going to get arrows going everywhere. I'm going to swap the k minus 1 here. And I'm going to swap the k minus 2, or k plus 2, excuse me, with n. And so at the end of the day, when I rewrite my power series, I'm now writing it in terms of the index n, not k. And I know I should start from 5. I should have n minus 2 squared. I should have c n minus 3 times x plus 4 to the n power.